Hello everyone, welcome back for another science video. Today we are going to be learning about Turgor pressure. So this is something completely new. We haven't talked about this, so you guys need to be paying attention. So the first thing we are going to start off by looking at is a plant cell. So Turgor pressure deals with plant cells. So I'm going to start out by drawing a plant cell for you guys just to kind of jog your memory of what that looks like. So here I'm drawing the nucleus. As you guys know, plant cells are shaped kind of boxy. So it's pretty much a green box. And I'm going to go ahead and label it. So we have our cell wall right there. We have our nucleus so that we know that this is a eukaryotic cell. And then we have our vacuole. So let's go ahead and talk about the vacuole for a second. So what is the vacuole? Well, the vacuole is where water is stored in plant cells. So if you got a shout out and I put your name in the shout out box because you answered yesterday's question correctly, awesome job. The vacuole stores water, guys. That's super important. Just water. So we are going to look at how the volume of water inside the vacuole affects the cell. So the cell isn't going to have the same amount of water in it all of the time. It's going to vary. And those variances are going to make the cell look different. So what I'm drawing right here is just our typical plant cell with a great looking vacuole. It has plenty of water in it. Everything's good. Everything's normal. So we have our vacuole, our plasma membrane, and then of course on the very outside we have our cell wall. And I put a check mark because this is awesome, this is great, this is a normal cell. Now let's talk about what's going to happen when the vacuole doesn't have as much water. I'm putting arrows to show you that everything's going to start going in. So let's look at a drawing of what that's going to look like when the vacuole doesn't have as much water. So there's my vacuole. It's kind of shriveled up because it doesn't really have a lot of water. And then that causes my cell to shrivel up too. So that's not going to be a cell that has enough water. Something's wrong with it. It's a sad plant cell. It's sad because it doesn't have enough. Now I'm going to go ahead and show you guys an additional demonstration with these bags of water and some pipe cleaners. So here we have a full bag of water. It's sturdy, it's full of water, it has everything that it needs. We can see that the pipe cleaner fits perfectly around it. So the pipe cleaner is going to be our cell wall, and the bag is acting like our vacuole. What happens when we have a funny shaped vacuole that doesn't have enough water? Look at our cell wall. We can't really make it into a perfect shape. It's kind of funny looking because it doesn't have any support. There's no vacuole to help support it, so it kind of falls down. So the more water that's inside of the vacuole, the more structure the plant cell has. The more water that's in the vacuole, the more structure the plant cell is going to have. The vacuole is going to be pushing out on the cell wall. And this is what we call Turgor pressure. That's all that it is. So we're going to go ahead and move on to looking at the formal definition of Turgor pressure. You guys have already seen the visual. You know that it's looking at how the vacuole is filled with water and how it's able to press out to make the cell wall move outward. So the Turgor pressure is the force within the cell that causes the plasma membrane to push up against the cell wall. So Turgor pressure is what's giving the cell its structured shape. We looked at that plant cell. We saw how it's shaped like a box. It's shaped like a box that has lots of structure. Turgor pressure is what gives it that shape. So here I am drawing another cell for you guys so that you can see this is what a cell looks like with good Turgor pressure. It has that classic plant cell shape. The vacuole is full of water. Therefore, the cell has its nice boxy shape that we normally see. So now let's go ahead and look at how does this affect plants? Okay, like we see the cells, but how is this actually going to affect the plant? What is it going to make the plant look like? Well, that's what we're looking at right now. We're going to see how the cell either being nice and full makes the plant look, or how it being more shriveled makes the plant look. So let's look at a plant that has good pressure. It's going to look like that example of the good cell that I showed you. So our plant, it's standing nice and high. Flower is happy. It looks healthy. Everything's good. So, and just to show you guys the cell again, so we have boxy cell with good structure equals flower. Hey, our flower is happy. It has good structure, good pressure. Let's look at what a flower is going to look like when it has bad Turgor pressure. So, wait a second. It's not looking, what? It's drooping down. Our flower looks sad. What's happening to it? What's happening to this flower? Why is this flower bad? What is the cell going to look like? So you see me drawing the cell. It doesn't have any structure. So therefore the plant can't have any structure. So this causes the plant to wilt. Bad Turgor pressure causes wilting in flowers. So let's look at, is this something that's internal or is it external? Let's think about that. Internal or external? So this process is taking place in cells that are inside of the plant. So take a second, think. Is this going to be internal or is this going to be external? Let's see. It's internal because it happens inside. Kudos to you if you got that right before I even circled it. So I'm going to give you guys one more example to look at to kind of allow you to make that connection. So here I am drawing my two plants. I'm drawing my plant that's happy, it's healthy, it's standing upright, and then I'm drawing my sad, wilted flower. It's not happy. It doesn't have enough water. Whoever's been watering it hasn't been doing a great job. So this is, as our Turgor pressure goes up, our plant also stands up taller. But as our Turgor pressure goes down, our plant also falls down. So that's the connection I want you all to make. Turgor pressure up, plant up. Turgor pressure down, plant down. But that's all for today, guys. Thank you so much for watching my science video, and I will see you guys back tomorrow for another one.